class, transmission distribution class 5. I'm discussing here the sag in overhead lines. What is sag in overhead lines? It is well known that when a rope is suspended between the 2 points, then it shows a tendency to sag down. Similarly, when a wire or a conductor is suspended between the 2 points, the wire sags down. The wire takes the shape of a catenary or a parabola. You can see that in the diagram, what I have shown here in the first diagram. This sag plays an important role in the mechanical design of the overhead transmission lines. The transmission lines are designed actually primarily from the economy point of view. To have the lowest cost, the length of the transmission line must be as shown in the figure. But due to sag, it requires more conductor material. Similarly, if the sag is more, then an extra height of the supporting poles is required. This increases the cost. Hence, keeping cost minimum, sag also must be kept minimum. Because economy, we have to keep whatever we design, it should be economical. But if sag is too low, then wire gets subjected to an extra tension. There are some other factors present like temperature, wind pressure, etc., due to which conductor gets subjected to the maximum stress. If sufficient sag is not kept, then conductor cannot sustain under such, actually it cannot sustain that kind of tension, and there will be possibility of the mechanical failure of the transmission lines. That's why the minimum sag and less tension cannot be satisfied simultaneously. So that is a challenge for us. Hence, we have to design the sag value considering all the severe conditions such that the tension in the conductor is always well within the safe limits. Such severe conditions may include the ice coating on the lines, high wind pressure, etc. because it is exposed to atmosphere, right? Hence, it is necessary to study how to calculate the sag and the tension in the transmission lines under widely varying environmental conditions. We don't know, we cannot predict the environmental conditions because it is exposed outside. Over a transmission line means it is exposed outside without any cover to the conductor. So this concept will explain us the sag and tension calculations in overhead transmission lines, which is nothing but the mechanical design of the transmission lines. Here in this topic, we also study the sag template and vibrational damper, whichever it's used in the transmission line design. So you are looking at the diagram. You know that between 2 points A and B, a wire is suspended. You see the vertical distance, S. I have shown in the diagram that S is nothing but a sag. Okay, it's called as a sag. Then how do you define a sag? It's nothing but the transmission line is not fully stretched, but it is allowed to sag down. You see the point O is the lowest point of the conductor. You can see here. Okay, so this is the vertical distance from the midpoint of the span length to the lowest point of the conductor. The difference in levels between point of support and the lowest point on the conductor is actually called as a sag. I repeat, the difference in levels between point of supports and the lowest point on the conductor is called sag. The sag is denoted by S. I've shown that in the diagram. What are the important points related to that sag? You have to note down some important points here. The one is when the supports are at the same level, then shape of the conductor will be catenary. The shape of conductor is called sag span curve. If the sag is small compared to the span, then sag span curve is parabola. The tension at any point on the conductor acts tangentially. That I have shown in the second diagram. You can see that it is acting tangentially. Can you see that? That you please note the second diagram. the tension here, it's noted down. At point at point O on the conductor, you can see at point O on the conductor, the tension TO acts tangentially. This tension has two components, one acting horizontally while other acting vertically. The tangent direction at point O is horizontal. Thus, the tension at point O acts horizontally. This horizontal component of the tension is constant throughout the length of the wire. Thus, horizontal component of tension is H. That is here at point O, that will be horizontal to the point wherever it is acting. Even at B, it's shown. But the horizontal, this T, whatever I have shown here, it has two components. One is horizontal, other one is vertical component. Now, how do you calculate? Because when first calculation will go, calculation of sag when supports are at equal. Supports are at equal levels. How calculation of sag is done? That it's explained in this. So you have shown the diagram here. You can see the diagram. According to this diagram, let point O is the lowest point on the trajectory. Mathematically, it can be proved that point O is at the midspan. Consider a point P on the conductor and let point O is the origin. The length of span L is large compared to sag S, hence the shape of the conductor takes the form of parabola. As the curve is very small due to small sag, it can be assumed that the length OP of the conductor here is same as the x coordinate of point P. I of O, L of OP is equal to x. Now there are two external forces acting on the portion OP of the conductor. One is, you know, the tension T. Other one is the weight Wx, W into x, which acts at a distance of x by 2 from the point O or P. The tension T acts in a horizontal direction at point O. Taking the moments of these two forces about point P and equating them, we get y is equal to Wx square by 2t. You can see here, y is equal to Wx square by 2t. Here, the sag, after substituting that, here applying the limit at support, say x is equal to L by 2, y is equal to s, the sag we get WL square by 8t. This is actually the required sag when supports are at equal levels. This completes